Hi there. Welcome back to Nexus, your go-to channel for all things informative and educational. I'm Mario, and today we're diving deep into one of the most fundamental concepts in mathematics, functions. Whether you're a student trying to grasp the basics or a curious mind eager to learn, this guide will help you understand what functions are, their types, how they work, and their real-world applications. So let's get started. Let's start by defining what a function is. In the simplest terms, a function is a rule that assigns each input exactly one output. Think of it like a machine. You put something in, and it gives you a specific result out. Mathematically, we represent this as slash and f of x, where ff is the function, and x is the input. For example, if we have the function f of x 2x plus 3, and we input x equals 4, the output would be f of 4 equals 11. Easy, right? Now let's move on to the different types of functions. First, we have linear functions. These are the most straightforward and look like straight lines when graphed. They follow the formula fx mx plus b, where hm is the slope and b is the y-intercept. Next, we have quadratic functions, which are those classic U-shaped curves or parabolas. The formula for this is f of x ax squared plus bx plus c. And depending on the values of a, the parabola can either open upwards or downwards. Exponential and logarithmic functions come next. Exponential functions grow or decay at an increasing rate, while logarithmic functions, being their inverse, grow much more slowly. Finally, there are piecewise functions. These are defined by different expressions based on the input value, like a function that behaves one way when x ln 0, and another when x GQ 0. When it comes to evaluating functions, it's all about substituting the input into the function's expression. For example, to evaluate f of x equals 2x plus 3 at x equals 5, simply plug in the value. F of 5 equals 5 plus 3 equals 13. But it's also important to talk about brackets here. Brackets help clarify which part of the expression should be evaluated first. For instance, in the function fx equals 2x plus 1, the bracket makes sure we add the values inside first before multiplying. You may be wondering, why are functions so important? Well, functions are everywhere in the real world. In economics, for example, supply and demand relationships are modeled using functions. In physics, functions describe how objects move over time. Population growth in biology, interest rates in finance, these are all modeled by functions. Let's take motion as an example. The equation s of t, ut sfrac 1, 2, at squared, describes the position of an object over time. Here, t is time, and the equation gives us the object's position, demonstrating how functions play a role in our daily understanding of physics. So to wrap things up, functions are a core part of mathematics that help us understand relationships between variables. Whether you're calculating interest, predicting population growth, or simply analyzing motion, functions provide the framework to solve these problems. And don't forget, using brackets correctly in functions ensures you avoid mistakes when calculating values. I hope you found this guide on functions helpful. Be sure to hit that like button if you did, and don't forget to subscribe to Nexus for more educational content. I'm Mario, and I'll see you in the next video.